Hi there, new episode of Playing with Junk. I got a TV studio. Yes, you can see it, it's already quite old. It's running on Windows 3.1 and it doesn't work very well, so we got this from a big customer. They had their own video studio to make educational videos for their employees, and I think before we throw everything away, there are a couple of interesting parts inside, and let me show you what it is. The first part I show you is a GML Excalibur. It's a mixing console for, well, it seems 4 channels, 2 times 4 channels, for foregrounds, 4 backgrounds, whatever. It's named channel A and B with a couple of effects and a nice slide lever here and a cool joystick here that can move to either side, and it can also turn. To explain a little bit how this analog mixing consoles work, I switch over to this model here. That's the Cox Vision Mixer T8. All this stuff here is from the mid-80s to early 90s, so it's pure analog, obsolete, low definition video. We have 8 foreground inputs. You can use them for 8 cameras, for example, or a couple of cameras and a couple of video recorders, whatever you need. Then you have a background selector, so you're always changing from a background picture to a foreground picture. That's what you do here. And then you have some selector of wipe patterns. You may be familiar with this when you're using a video editing software. You have different patterns, like for example circle that opens or closes for the next scene, all kind of rectangles from the left, from the right, and then you simply move the lever to wipe to a new picture. That's the idea here. Then you select which camera you want to use or which video source. For example, you can use the PC here as a video source for graphics or whatever. You can have backgrounds that are not necessarily backgrounds like in a new studio. It just could be any video source that you can switch between fore and background. And there are a lot of functions. I simply don't know how they do, because it's not doing a lot. I have tested it. I get an output signal when I feed an input signal to channel 1, but everything else doesn't change. So that part here is only the keyboard, if we can call it like that. It is connected via this cable to the big box here, and that's where all the logic is installed. So let's open that. Oops, a bit difficult with one hand. Okay. So we can see a lot of huge boards, a lot of lamps that are working somehow, and here we have nicely a schematic diagram, which board does what. So the top board is the video processor, whatever that does. What I think is interesting, we have a wipe pattern generator, or two of them. That's the two boards here. That means the two boards here are only used to generate this wiping pattern that we saw on the keyboard. So I will switch that off. That's the power supply, various control LEDs for, and they also have these plugs here where you can insert your probes from the voltmeter. 0 volt, that's ground, 5, 15, 24, and so on. Okay, let's put one of the boards out. That's board number 1, 2, 3. That's one of the wipe pattern generators. And it's a mixture of digital and analog circuit. There's no microprocessor, nothing like that involved. It's just video signal playing with that. So there is another one. It looks like we have a little bit of memory here. Maybe part of the video signal will be stored. That does also look like memory. 74 LS377 and 4051. Maybe that's some sort of flip-flops. Digital to analog converters, 1, 2, 3, 4. Probably for the 3 colors, and well, I don't know. I'm just guessing here. That's the split screen generator. That means it generates well, 2 pictures in one screen. We have 1, 2, 3, 4, 5, 6 digital analog converters. So they obviously make a digital signal or a digital pattern and convert it into an analog signal form that can be displayed on the monitor. Okay, what else? Foreground key etcher. That one. What is that? Goes pretty hard. Okay, there is an EEPROM or a PROM, a programmable ROM. Digital etcher, yes, that looks pretty digital from the layout of the board. There is a little bit analog in this corner here. A lot of stuff, and certainly quite expensive in the days. Propo 87 date code 86, so that's around that, 87, yes, late 80s, early 90s. So microprocessor board, yeah, there are the big chips. We have Zilog Z80, yes, Z80 CPU, DMA, direct memory access, PIO, parallel in and out, DART, dual asynchron receiver transmitter, counter timer circuit, everything is labeled, that's nice. Some RAM or ROM, yeah, that's a typical, more RAM, more ROM, some kind of connector and a battery that is leaking. Maybe that's the problem of the entire box, who knows. Then we have a bus orbiter, whatever that means. It controls the bus. That's the bus terminators here, that's the bus connectors, and whatever that board does, it does it relatively slow. We have 4.00 and so on megahertz. Yeah, and a few selector switches. Yeah, I don't know. It's difficult to find some manuals about this stuff, because that has not produced in high numbers, and it was way before the internet. So it's a little bit, that board looks like the other microprocessor board. So it seems we have two of them. Let's compare them side by side. Yeah, I don't see much difference. Even the switches here are in the same position. Yeah, the same amount of chip, the same Bosch wire. Okay, I think it's 2 times the same board, so we have 2 CPUs in this unit. Okay, let's see. Key processor. That's the big one, or one of the big ones. Okay, we have relays, most likely for switching input and output channels. A lot of analog stuff, and 4052, that could be analog switches. I don't know, I don't have the data sheet right now. CD4052, if you want you can look that up, what it is. Voltage regulators, more voltage regulators. That looks like a delay line that is used to decode the video signals, stuff like that. Mask processor, okay. And a hell lot of trimmer resistors, pots. So I think to set this board up properly and configure it and adjust it, that takes quite a while. So let's see what the last board is. It is a video processor. Yes, it's written here on the board. Looks even more spectacular. We have 1, 2, 3, 4, 5, 6, 7, 8. That's some of the inputs and output drivers, probably. Here we also have 2, 4, 10 of them. Okay, for 8 channel. Whatever. That could also be a delay line with 5, 10, 20, 40 and 80, don't know, nanoseconds, milliseconds, whatever. Something you can plug in. Okay, with 3 wires. Maybe critical to which position it goes. A lot more of this 4051. Yeah, and a hell lot of analog potentiometers and some digital switching stuff. Digital analog converters again. Yeah, a lot of DACs. You can see them, DAC, digital analog converter, clearly marked. The fuse, a lot of voltage regulators. That box creates a lot of heat. And at the end, you have something you can use in the same way as you use your video editing software on your PC or on your Mac, but here in a pure hardware style. So This box can do whatever components are mounted here, and if one board is not there, the function is not there. You cannot simply install that with a software upgrade. And of course you also need tape machines, all kind of video recorders, because this unit does not store any frames or any sequences of video. It's a pure input and output switching and manipulation system. Let's have a look at this PC. It's the same age, 1990, maybe even 80s, and it runs Windows 3.1. Windows 3.1 was, well, the first really successful Windows version. There have been Windows 1 and Windows 2, but I don't know anybody who used those. Then Windows 3 came out, 3.1, 3.11, and then the next big step was Windows 95, so we are definitely before 95. We have some programs, we have a control Windows system control, we can customize our desktop. So this system here, this PC, was not used for video editing, it was used for creating graphics, for example with Corel Move. That's a program to create short animated clips. So there is nothing, but we could open, I think there is a sample. It takes a while to load, it's not the fastest system. But it has 8 megabytes of RAM, wow, which was quite a lot in those days. There it is. We see the wonderful animation of the dollar character that jumps on the desk and shows you how your business is working. That's the example movie and stuff like that could be created on this machine, and then via the video mixer back to the tape, or maybe even to a CD. Yes, it has a CD-ROM here. Yeah, that's about it. And we're going back to DOS. And in those days there was no shutdown procedure. Well, you went back to DOS and then you pushed the power button. And I'm pretty sure you want to see inside this PC, so let me show you that. Let's see what's inside this PC here. The first problem I had to make it run was to find a mouse with a serial connector. Well, of course there are adapters from PS2 to serial, but the problem is not all mice speak two language. So I had to find one of the earlier Logitech PS2 mice that were able to work with the PS2 protocol, and also, well, protocol is a little bit too much. It's just a different signal level, and the pin, and it's a different connector, of course. But the mouse must be able to switch between the 5-volt TTL level here and the plus minus 12-volt RS232 level on the serial port. Newer PS2 mice do not have that function, so you can plug them in, they won't work. That was the first problem I had. And the second problem was to find a keyboard with the large DIN plug here. That's in fact a little bit easier because there are also adapters from the large to the small PS2 plug, and they are compatible, so that's in fact the same as a PS2 but with a larger connector, so any PS2 keyboard can connect with an adapter to the bigger size connector here. I said this PC also has a CD-ROM. It has one with a door, not with a drawer, and this works by using a caddy like that. You have to depress the corners, open the caddy, put the CD in, close it, and insert it here. The caddy system is a relatively good idea if you have one caddy for each CD you own. If you only have one caddy for all the CD and you have to change them all the time, it's a really awful idea. And the caddies were not cheap, so that's why they changed the system for a drawer. So caddy, nice idea. You can store your CD in the caddy, it never gets dirty, it never gets scratched, but you need one caddy for each CD. And that opens like so. The laser then can read. Okay, CD with a caddy. The first CD-ROMs had this system. Okay, enough noise for today. What else is inside here? We have hard drive. It's a Quantum ProDrive 425S, and that means it has 425 or 26 megabytes, which is quite a lot for the time. That's almost half a gigabyte, and that's insane. You will also notice there is a processor down here. Oops, let me show you that a little bit closer. Yes, it's a Intel 486DX, and you will probably notice that it has no cooler on top. That's because it was not necessary to cool these chips. The old chips, 386, 486, even the first Pentium, I think, they were not active cooled. They just didn't get that hot. It's okay. And the empty socket here is for a mathematical coprocessor that was rarely used in the days. It was expensive and most software packages didn't have a benefit from having this installed, so the software must be able to work with that. Okay, what else do we have? You may notice there are quite a lot of boards plugged inside. That's because the main board itself has absolutely nothing on it except the CPU and the RAM. So we have a graphic card with a Paradise chip, some video RAM here, ROM, analog to digital converter, and then output. That's it. And the ISA bus. That's not PCI, that's not PCI Express, it's not PCI-X, it's the 16-bit ISA bus. This part here is the 8-bit bus, so if you only have 8-bit sockets, you plug in this, leaving that part hanging out at the end, and there are the other 8 bits making a 16-bit bus. Then we have a monster card here, which is another video card. And I found out there is nothing labeled except some part numbers here, made in USA. Where else? That must be a TGA or Targa card from 1987, I think. And that's one of the first video cards with an actual video processor, with a GPU. That's the first GPU inside here. I will show you that. There is RAM, a lot of video RAM. It's 32 chips. Here, one row. Half of the chips on the lower board, half on the upper board. 32 by 1, 2, 3, 4. 4. And each chip has a storage capacity of 265 kilobit. So you may start your calculator. 32 by 4 by 265 kilobit. You can multiply that, and then don't forget to divide by 8 for kilobyte. I will tell you how much that is. Well then, did you turn on your calculator? Did you get 4 megabytes? Well, that's it. 2 megabytes here, 2 megabytes here. That's memory extension. Then we have the famous TMS 340010. That's the very first graphical processor, single chip GPU. It's a microprocessor design, but with special instructions for graphical applications like drawing circles or drawing straight lines. True Vision, that's probably the manufacturer of this card. Copyright 1987. And you probably ask yourself what these letters here mean. That's the initials of all the engineers that worked on this card. For example, CC and KF and BH and so on. There's quite a lot of people working on that board. It's version 3.0, whatever the other versions have been. And then there is the analog board that comes here with the, it has an in and an output. Well, certainly you hook your screen here to the output. I don't know if you can use the input to capture pictures from other graphic cards or mix them together, make one picture from two. And I think there is a lot, yes, video DAC, digital analog converter, for I think one for, yeah, it's even labeled. It's the blue, it's the green, it's the red, and that's the alpha channel. That means the intensity, the black level. Is that right? Yes, something like that. That's clearly labeled. So you have one individual digital to analog converter for each color, which will then go to the output here, and on the monitor they were mixed together with the 3 pixels or GMB, red, green, blue. Yeah, that's the analog part. That must have been a very expensive video card in the days. I found something similar, but without this additional board, just one board, was $5,000 in 1987. So that was probably a $10,000 card today. Okay. By the way, 4 megabyte of picture memory. That means a full 24-bit resolution per pixel, or 24-bit color resolution at let me see, I made and 1.3 megapixels. That gives a resolution of 1280 by 960 with true color, 60 million colors, and that 4 megabyte is enough to store 1 picture. That picture you actually see on your monitor. Okay, next card, next board. What's that? Oh, that's a network card. Classic. We have RJ45 as we know it today. We have BNC, that's 10 megabit per second. With a bus system, you hook all the computers were on one single cable. So the cable went from one computer to the next, so you needed a T plug here. And on the last computer you had a terminator. And if one user unplugged the cable, well, it was no problem here, but if he opened the cable, so everyone in that floor lost network connection. And that's the AUI connector. That's where you can connect an external converter to, for example, RJ45, another BNC, or whatever system you have in your building. Yeah, that's a 10 megabit network card, MAC address, made in USA. Then we have another card, and that's just serial, parallel, and there's another serial COM port. A lot of jumpers to set up the card, like the correct address. So if you have multiple cards, you have to change this for each card and so on. Pretty simple stuff. Serial card. On a modern PC you have that on the main board, of course, serial ports, parallel ports, but in those days you have to buy everything extra. Then we have this monster card here. We have external SCSI. It's an 8-bit large plug. That's something you usually had for external devices. Internal SCSI, also the 50 pin is also an 8-bit bus. It's not SCSI wide, it's SCSI narrow. That's a connector for the floppy drive. So all that stuff you normally connect to the main board needs an extra card. Adaptec, SCSI chip, ROM, another ROM, another Z80 CPU, nice. Some switches all on open, okay, don't need that. And of course also the ISA bus here. Then there is the SCSI cable going to this hard drive. That's the floppy cable, goes to the floppy drive, of course. Well, I removed some of the cables so you can see the main board a bit better. That's the buses, all 16-bit ISA bus, one 8-bit bus here. Then we have 8 megabyte of RAM. That's the old 30-pin RAM. Okay, I have to start at the back here. 230 pin, that's 1 megabyte. 8 megabyte in those days was quite a lot. So for example, DOS had a maximum memory of 640 kilobytes. If you wanted more, you had to install additional software to handle this enormous amount of memory. Then, for example, the power supply has this tiny little connectors here. That's the, well, I call it the AT connector. I don't know if this is the official designation, because the newer are ATX connectors. That's the extended AT version, because AT was the first IBM PC. The first one was the XT, then the AT, Advanced Technology, then ATX, and so on. And so we have also this big cable here, which is a 230 volt mains cable that goes to the power switch, which is here in the front. That means you have a mechanical switch to switch the power supply on or off, and that means if you shut down your PC, you have to switch it off manually, because there is no way for an automatic switch off. There's no relay, there is no, well, maybe you could install a relay somehow, but it was not meant to have that. And if you look at the board, the only I/O connector that was left is this, the keyboard connector, the big one. There is a serial connector, but this is not connected to the main board. That was connected to our serial cable. There's the cable here, it's unplugged now. So the only connection you have on the main board is the keyboard plug here, and that's it. No onboard graphics, no onboard Ethernet, no onboard anything. Just CPU, RAM, BIOS chips. That's the cache RAM. You could install them or not. You could operate your system without cache. Of course, with cache it was faster. Then, as I said, arithmetic coprocessor, and that's it. Just a bunch of sockets. So you would need at least a graphics card, even if you want to use DOS, and you need a card to connect all your peripheral devices. There is no USB, of course, it has not been invented. Then there is also no floppy connector, no hard drive connector, nothing. Okay, that's for the PC. I said these panels here are more or less only keyboards, because all the logic stuff happens in the big box. Well, it turns out there is quite a lot of stuff inside here. All these switches and indicators, they of course are operated by an own microprocessor here. All the I/O boards, so that looks more like a keyboard here. That's all the control that connects then to the box. And most interesting here are those joysticks here, because that's the really expensive and interesting stuff. So you have two potentiometers, one for one direction, the other for this direction, and then we can also turn, but I don't see where that switch or potentiometer is. Maybe it's just a position switch. Maybe I think it's here, because the potentiometer is attached, is connected here. That's the big lever here. It feels really expensive. It has plastic stop screws here that can be adjusted, and because they are plastic, it doesn't slam too hard into that stop. It's a little bit springy. That's good. And we have, of course, a lot of nice and illuminated keys. So I think I will take that apart and keep some of the keys and switches. And of course, it's almost the same for that panel. So I will probably keep some of the nice colored switches with the LEDs. This one has incandescent lamps inside, and I already found one that is burned out. So there is a lamp test. When you switch it on, all the lights go on, and you can see if one is not working. Yes, I think that's it. Thanks for watching.